Okay, next module is math. Let's check the methods of the math module in, again, Python 3 command line environment. You can first import math, then we can use math module for printing like some constant numbers like math_pi prints the pi number, or math E prints the Euler's number. We can make some calculations like math_pi times like pi times r, for example, which is the area of a circle. Like if the r is 2, then the area of that circle is 12.5. We can use the math module to print the sinus of an angle, but like if you type math sine 30, you will not see 0.5 because this module's default unit in degrees is radian, actually, not degrees. So to convert the degrees to radian, we can use this math radians. So math sine math radians 30 will print out 0.5, or like we can use this cosine, cos for cosine. Cosine 30 is 0.866, or we can use it as cotangent. I don't know why it doesn't work with cotangent, but it's fine. You can just check it on the internet for the cotangent. We can use sqrt to take the square root of a value. Math sqrt 4 prints out 2, or like 16 prints out 4, or you can just do it for something else. POV means power. We can print power of a value by giving two values here, like 2's third power is 8, or like 5's second power is 25. Factorial is the next method, can be used in math. Factorial of 3 prints out 6, for example, 3 times 2 times 1, or like 4 will be print out 24, which is 4 times 3 times 2 times 1. We can check if a value 1 is close to value 2 by giving the relative tolerance. Like math is close. Let's check 2.5, 2.7 by giving the relative tolerance, which is 0.2, will print true. But if we type here 8, okay, it is not 0. If we type here this, it will print out false. We can use this is close when we check if like a number is close to the items or elements of a matrix, for example. You can use this one is for arrays. We will learn in the next part of this lecture in numpy. The other thing is log, the logarithmic function. Math log, for example, 110 will print out 2 because 100 is the second power of 10, or like math log e, math e will print out 1 because if you don't type anything for the first value, the default is e, so this is ln e, which is 1. We can convert the degrees into radian and radians into degrees by using these two commands. The next one, of course, we can again use the math in files, like open a file like a.py. We will remove it again later. Import math. We can print math_pi. or we can calculate, if r is 2, we can calculate the area, which is equal to math pi times r square, and print the area of a circle with radius of r, but string r, is string of area. Then we can save it and press F2 to run. It prints out the area of a circle with radius of 2 is something. Okay, I will not save this. I will remove this a.py to keep this folder clean. Then next module is numpy. Numpy is actually numeric Python. It is used for array operations. In data science or the mechanical engineering calculations, we use numpy a lot. Actually, it is the module which is like mostly used in Python. So it's a little more complex than the other modules and the previous parts of our lectures, but it's better for you to learn numpy quite well. So I recommend you to focus on this part of this video better. Now for the difference between lists and arrays, we can see this figure. This is my fourth code. Again, I will copy my fourth code from my this directory. You don't have this directory, so you need to write this code by yourself. Now here I make two lists which are L1 and L2, list 1 and list 2, and I make two arrays using numpy which are array 1 and array 2. Okay, now addition of the lists can be printed out with str, which is string, L1 plus L2. In this case, Python will add this array, this list here, and it will print 2, 3, 5, 7, 11, 13, 17 and 19. But when we make addition with arrays, which are created by this command, this method, numpy array, parentheses, square brackets, the elements of this array, close the square bracket and parentheses, and a2. When we add these a1 and a2 as numpy arrays, it will add each elements to each other and print 13, 16, 22 and 26. Okay, the difference between lists and arrays is this one. When we multiply the L1 with 2, it will print 2357, 2357. It will just multiply this one as like string, but when we multiply arrays instead of lists, it will multiply 2 by 2, 3 by 2, 5 by 2 and 7 by 2, and it will print 4, 6, 10 and 14. Okay, like let's see first the output of the first part, this one and this one. I will see 4 lines of output. What I do, I just save my code and press F2, and like as I said, when we add two lists, which is one of them here and second one is here, it adds them like row column wise. But when we add two arrays to each other, it adds the numbers in these arrays, the elements in these arrays, which are integers here in this case. Okay, and multiplication is also made when we multiply this array with 2, this list with 2, it prints that list 2 times. But when we multiply this array with 2, it multiply each element of array with 2. there is one more difference here we can see. Lists are printed with comma separator as shown here, but arrays, in the arrays there is no comma. The separator is just a space. Okay, now go back to our code and open these three lines. We can convert this list into array just by typing numpy array and in the parentheses the name of the list. Then it will print like A3, which is defined here as I said, and F2 as this one. L3 array is converted to L3 list is converted to this array. Okay, there are no commas, so this is an array. Now here we can access the elements in the lists and arrays in different ways. I will just save my fourth code.py and close it. I now have here first, second, fourth and third codes. I will open my fifth code.py. I'm again copying my fifth code.py, but you need to write it. Now I recommend you to stop this video, pause this video here and write this code and then continue watching. Now here I make a list of 3 elements. These are 1, 2 and 3 of 4 elements in each. So this list is 3 by 4 in 3 by 4 shape, or it is 2-dimensional list. We can also make the same array by adding numpy array in front of it, and then here we just print the second row of each list and array. Second row is just here, and the index of this second row is 1 because Python starts counting from 0. This is 0th element, this is first element, and this is second element. So when we just say second row, we just understand this one, but the index is 1. Okay, when we print by doing this, both will print this one here, 29, 31, 37 and 41, and this one here, 29, 31, 37 and 41. The difference will only be the commas. Okay, now let me comment out this part and then save and run this command to see only these outputs. So this is my first output, this is the second output, as I said. When we print the third element of the second row, which is the third element of the second row. Second row is this one, and the third element is this 37, because I type here 2. Okay, we can use this method for printing from lists and this method for printing from arrays. It differs here. Okay, it differs here in this case. Again, I will comment out this part, and let's also comment out this part, and then just run the code. 37, 37. Okay, the output is the same, but the input is different here. But when we want to print like multiple elements in each rows, like the third element of each row, when we want to print an element of multiple rows actually, then we can just use this way of printing in arrays. But as far as I know, we don't have a easier way for printing the third elements of each row from the list. Isn't there any easier way? So we need to print them one by one, like 0th elements third element. So in the list, 0th element is here and the third element of that is 19. Then first element and third element, like first element is here and the third element is this one. Second and second is 53. So in this case we will print 19, 37 and 53, but to print these 19, 37 and 53 in arrays we can just use this column. Okay, just do that, save this and press F2 to see the output. Okay, in Python, in our field of study, we usually use arrays instead of lists for working, and because it's both easier and faster, as you see here, and it's much more powerful. Okay, now in numpy there are some data type definition. Here in this case our data types are integer. Let's save this fifth code and exit. I now have from first to fifth codes. I will copy my sixth code and open the sixth code. Please stop the video here and write this code. Now here we can both use the integers and strings and floats as numpy arrays. Okay, here we just made three different arrays having integers, strings and floats, and we can just print their type using this array name dot dtype method. Okay, to just print this part I will comment out the last and then save and press F2. As you see, my first array is in integer format, my last array is in float format, and this one means the string. We can change the array, we can change the type of an array to something else, like to string, as just by typing comma then dtype equals to the type you want. Here, as you see, it was like u1 something. The type of this one was like u1 something. When we generate this array, if we just write comma dtype equals s, we can just convert this array's type to string s. So when we print a4 type, we can see that the type of A4, I saved and pressed F2, type of F4 is now string. We can also change the data type of an integer array to string just by typing the same thing. Save it and run the command. You see that the type of your last array is string, which includes actually integers, but when we write this we can just change it to string. It is also possible to change an array's type to integer with 64 bytes, 32 bytes, or float with 64 bytes. For the details you can just search on the internet. I will print all of these three data types, and I will also print this A8 array, which includes integers, but we change its type to float. Okay, when we change this one's type to float, it will do something, and you will see it here. Again, we will work on these in the future when we write some advanced codes, and we will see why we want to use like 64 byte integer or like 64 byte floats. Okay, now just print these by pressing F2. Now the first array's type is integer 64, integer 32, and float 64. When we convert an integer array to float 64, it just puts here some dots, which means this is not an integer number 2, it's a float number 2.000. Alright, now save my 6th code and exit. Now I will copy my 7th code for the next instruction. And open that. Now please stop here and write this code. Here we can print the shape or dimension of an array. Here we made our A1 array including only one element, only one row. Here we have 2-row array, and here we just make a 5-row array using this ndmin. First come to this A1 and just comment out this A2 and A3. When we do this, it will print the numpy, it will print our first comment, this one actually here, to make the output better, and then it will print the dimension of A1 when we use this A1.ndim method, and it will print the shape of A1 when we use this A1.shape method. Save it and press F2. You will see that the dimension of A1 is 1, so this is a one-dimensional array, and the shape of A1 is 4, comma. If there was another array here, if there was another row here, we would see 4, comma 2, because there is no, we don't see 1 here, so this is one-dimensional array having 4 elements in it. Alright, so to see the difference, you can just open this and then save it and press F2. Our A2 array is a 2-dimensional array, which is written here, and there are 2 rows and 4 columns in this. When you print A2, you will see that you have 2 rows and 4 columns, 1, 2, 3, and 4. Okay, 2 rows and 4 columns. When you print A1, you will just see this one. So this is 1 row and 4 columns. Okay, there's a difference between this one and this one. Please consider this or have a look at this. We can just create a 5-column and 5-column and 4 rows array. This is 5-dimensional array by this, and you can print. Okay, A3 array is here, dimension and the shape. Run the code to see the A3. It starts from here. We use this command numpy array, an array, and means something, and A3 is just like this. There are 5 square brackets here. Dimension of A3 is 5, and we have a matrix in this format now here. I don't know when to use this, but there's an option creating like multi-dimensional arrays, so-called ndmin in numpy, as shown here. Save and exit the 7th code. We can reshape the arrays in our 8 codes. You should write with 8 code dot py. I will copy it. and stop here and write this 30 line code in your 8code.py file. Now here we have A1 array having 8 elements in one row. Shape of our A1 array can be printed with A1.shape. Just comment out this, save it and run with F2. As you see, the shape of A1 array is 8, we can reshape this array just by typing A1 dot reshape 4 by 2. When we write this code, our A2 array will be printed, and then shape of A2 array will be printed with these options. Press F2 to see the results. So we shaped our 8 element 1 row array into 2 elements 4 row array, 2 elements 4 row array, which is so called A2, and the shape of this array is 4, 2 now. We can also shape it into 4 elements 2 row array. I just saved and press F2. 2 elements, 2 rows and 4 elements in each row. As you would remember, we were able to use -1 to represent the last element in the list. We can also use it like here. We can use it at the end in the second variable here, in the second value here, to represent the number of elements, and this is the number of rows. So we will make 2 row, and it will just divide 8, which is the shape of A1 array, by 2 to find this value when we write -1 to here. So if this is like 16 element array, it will divide 16 to 2 and it will write here 8. But this is 8 element array, so it will divide 8 to 2 and it will write 4 here. So just run your code to see your A4 array, which is generated by this command and which is made as this. The opposite is also possible, and we will look at it in our 9th code. Like if our array is having 2 rows, each 4 elements, which is 2 by 4 array, we can reshape it by putting the -1 here to 8 or like 8 element 1 row array, 8 element 1 row array, like this one. Oh, sorry, 8 rows 1 element array here. If we add the -1 here, if we add the -1 here and 1 here, it would merge these 2 elements. Let's try it. 1 -1 and run that code. You will see that our array is now has 8 elements in 1 row. Save your 9th code and exit. The opposite is possible. Now we can combine our arrays by using concatenate, stack, vertical stack, horizontal stack, or if we have multi-column arrays, like multi-dimensional arrays, two-dimensional, three-dimensional arrays, we can also use the column stack method. I will again copy my tenth code. Please stop here and write this code, which is first 30 lines can be seen here and last 10 lines can be seen here. Now let's first comment out the 2D arrays, then look at them later. Let's first have a look at the 1D arrays. We have two arrays which are A1 and A2. If we just write numpy.concatenate using double parentheses here, there's a warning here, double parentheses, we can just merge these two arrays to each other. When we use concatenate, it will merge them, like it will make them one row array like this. But when we use stack option, numpy stack, then it will merge these two rows like column wise. Now our first column is here, second column is here. If you print the shape of your array, you will see that this is 2x4 array. Now vertical stack can also be used, which is the same as concatenate, because it stacks, it merges our arrays, which is the same as stack, it merges our arrays column wise. And if we use the H stack, which is horizontal stack, it is the same as concatenate. So stack and V stack is the same, concatenate and H stack is the same. Okay, horizontal stack, H stack and concatenate are the same. Stack and vertical stack are the same. Now we can work with 2D arrays. Let's comment out these 1D ones. And then open these. A3 and A4 are 2D arrays made by these two commands. If we use concatenate option, we can merge them like this, because our first array is this one and second array is this one. Like in the 1D arrays, it merged them horizontally, but because they are already divided into two, it put the other two next to this two. When we use concatenate axis 1, when we use this axis 1 option, we can just change the merge method. So press enter, then it will put this 911 next to this 23 and this 1317 next to this 57. Okay, to calculate this one. Now we can also use, instead of concatenate and concatenate axis 1, this numpy stack, numpy vertical stack and horizontal stacks. Now as you see here, the stack is similar to this concatenate, but this time there are one more square brackets here. It's not the same, but vertical stack is exactly the same as concatenate, and horizontal stack is exactly the same as concatenate axis 1. You don't have to memorize these, but you should know there is something like concatenate and stack, horizontal stack, vertical stack. When you need these, you can come back to this library, you can come back to this repository, and you can have a look at these examples. If you want to merge your arrays in this way, you can use concatenate. In this way, you can use like stack. In this way, you can use concatenate axis one or like horizontal stack method. Okay, we are just showing now here you to have an idea that there are some methods to merge the matrices or the arrays. Okay, column stack can also be used as horizontal stack, column stack, like this one. This method, column stack, numpy.columnStack, is the same as hstack for for two-dimensional arrays. Now there are several methods can be used in numpy, several other methods, like we can sort arrays, we can check what is the index of an element in an array, we can split them, filter them, we can use a random option to make arrays with random numbers, we can set the lowest and highest numbers before creating these random arrays, we can choose an element randomly from an array with random choice. We can use this random permutation to mix the elements randomly in an array. We can create arrays having zeros or ones just by giving its shape into numpy. Okay, these are quite useful methods in numpy. And now please stop this video, go to the computer programming BTU and lecture 5 repository, find this picture under the other methods can be used in numpy, and click on this picture to make it larger for you to see better, and then write your which code is this, then element code having these, alright, and write these. When you write this part, press F2 to see these output. After writing sort, press F2 to see how numpy sorts these arrays. When you write var, press F2 to see how numpy finds the element 7 from here and here from one-dimensional and two-dimensional arrays, and make this example by yourself. And this is your last job in this lecture 5. We will continue with reading and writing files using numpy or not using numpy in the next lecture, in lecture 6. But now in the next video on YouTube you will see how to upload these files into your GitLab repository. Please make this example by yourself to have your elementcode.py, and then continue watching the next video.